So hello everyone, I am Priyanshu Kumar and I am currently pursuing BTech in Mechanical Engineering of Tech University. And now here I am to doing my examination assignment of Computer Aided Engineering which has given from our department. And the question was modeling and finite element analysis of an angle bracket using a suitable software package, and you can choose the relevant dimension of a bracket as per your convenience. So in our academics for modeling purposes we use the SolidWork and it is very good for modeling. So now I am going to open the SolidWork. Now here the interference of SolidWork. Now we have choose the part section for doing our modeling. We have choose the plane where we do the modeling. So I am choosing the front view because it is easy to understand the axis. So here is front view. Now go to the sketch section and I choose the line part for doing the sketching of angle bracket. Now I am doing the modeling. So here is sketch and doing the modeling. Now I am changing images. So it is this images. Then I sketch. After the modeling, we use the smart dimension for noting the value of dimension. So here is smart dimension. Here is also here is 16. Here is also 16. Now, after the dimension, we have extrude the angle bracket for the sufficient diagram of the extrusion, which I choose the 40 mm. It is used for modeling. So here is feature, then extrude box, and here is 40 mm for extruding. Then we'll lie on the midpoint because here now I'm clicking on OK, and here is extruded. Now it is extruded. Now that in the question we have to do two holes on the angle bracket which is between the plane. So then I click on the plane where I do the operation. So here is plane and we're going to sketch and I'm choosing the circle and here is circle. It's my dimension. It has radius of 20 mm. So now clicking the radius of which is 20 mm. I have choose the my side from the circle in the midplane. So here I am doing the small dimension for the midpoint of the circle from the top bottom of the modeling. The total length was 60 mm, so it is 30 mm. And the extruded part of the model, so the extruded part of the so it is taking the time. Now it is 30 and The extrude part of is 40, so it is 20 and it is correct. Okay, it is a midpoint. Now it is in good alignment. Then we have to cut the circle part from the angle bracket. So here we use the extruded cut section from the circle and go to the setting part to select the cutting distance. So here is feature, then extrude cut, and here is 40. So here I am choosing the up to the next because I am extruded the part only which I want, and here is okay. Now it is extruded. Same thing in the other side. Okay, I am doing here sketching circle, small dimension, the radius is 20 mm. There this was 20, it is correct, and the bottom is 30. Now it is correct. Then again go to the shortcut side, which is up to the next, and there. So it is extruded. Now 90% of the problem of modeling is completed. Now the last part of the modeling is fillet part, because fillet is the create a rounded edge or corner on the plane model. So here at the sharp plane we use the fillet. So click on fillet section, features and fillet, and edge or corner where you perform the fillet. I am choosing the this edge, this edge, this edge, this edge, also, I am giving the extruded dimension of 1 mm, applying it, and here is extruded all the way. We have extruded the back side of the bracket, so here I again use the fillet, then I use the edge, and here I choose the dimension of 5 mm because I want curved surfaces. 5 mm, and clicking. So it is completed. The modeling part is completed. Now we have to for the analysis purposes. So here I am saving this file +s, and the IG is from part 1, and from the bracket, end of bracket, sorry, saving on download section. Yes, 5 0. it is saved. Now we have done go into the Ansys section for the analysis purposes. Now the next part is finite element analysis where we use the Ansys software. So here I saved it file. Now Ansys help predict a product where performed in real world condition leading to safer, more efficient and more cost efficient design. Here now I open Ansys software for doing the finite element analysis. So and this is workbench, Ansys workbench. Now here it is processing. Now it is open. Now where we go to the static structure, then we have done our geometry in the SolidWorks. So here only I import the file, import geometry, browser, and import it, and it is open. The geometry part is done. So there is now right click on generate, then it is completed. Then go to the model part, and it is opening for where we perform a meshing part. Now it is open. Now here's model section where we generate a mesh. Right click on mesh and generate mesh. So it is generating mesh and it is undefined meshing. So we have to refresh the meshing part, refreshment of meshing. So right click again on it and insert, then refreshment. Now we have to choose the plane where we perform the refreshment. So here we choose the all of the plane. So there. Here I am choosing all the thing where we perform the meshing. So now apply and I selected all the domain. Then click on it, right side and update it. The refreshment is done. Now go to the static structure for giving the load. So for giving the fixed point, we have fixed the one part of the angle bracket for the analysis. So right click on it and insert and fix support. Here I am supporting the y-axis, so therefore I click on this plane, then apply on it, and it is fixed. Now we have to giving the load. So here is again right click on it, static, then insert, then force, and we have to again choose the plane where we apply the load. So here I am choose this plane for the applying the load. So here is it, and choose the vector to component part. Then there is a x-axis, so in the negative side of the y-axis we put the minus sign in the y-axis and giving the load like 10,000 Newton, and apply on it, and the load is given. Now we have to analyze the other part like the deformation, stress and strain. So we have to go to the solution section and right click on it, and then insert in deformation, the total deformation, then again right click on it, insert, and the strain part and the equivalent strain, then again to the solution, right click on it and insert, then stress and the equivalent stress. So now here is the process, then apply, right click on it, then solve. It is solving, it is processing for the next part. Now it is done. So here I am clicking the total deformation at it, and it is like this, and I am selecting it like here is the maximum total deformation after the load applied on it, and here is the equivalent elastic strain. Here is a maximum elasticity present after the applying the force, and here is the equivalent stress part, and here it is. So thank you for watching.